welcome to Graph Power Hour. This is our fourth episode. Thank you very much for joining us. My name is Paco Nathan. I'm from Senzing, and we are bringing you graph experts from around the world to talk about leveraging entity resolution and graph technologies together. Today, I'm really excited. We're joined by Thibaut Kellam, who's the head of customer success at Linkurious. And Thibaut also has a background in leading security teams in banking. So he has a lot of experience in the field with fin crime. And we have use cases here from customers to discuss regarding how to leverage interactive visualizations and graph analytics in specific areas of fin crime, such as, for instance, detecting money mules, which is a really hot topic lately. It's also a growing concern. It's also something very difficult to do, perform, because of the nature of the fraud. And there are other use cases as well. We'll go through this. And part of the other context here is that Linkurious and Senzing have been working over the past several months. There's an integration which is now in beta of using entity resolution in a no-code mapping inside Linkurious. So we'll explore this as well. So I would like to turn over now. Welcome, Thibaut. Thank you for joining us.
Well, thank you for having me. It's honestly a great pleasure and a great honor as well. And very happy to be able to speak and present the work around integrating your product within ours. I think it's a very powerful partnership. Very excited for all the opportunities that would bring and all the business challenges that we will cover and challenge with that. So, I mean, let's get started. We have a lot of topics that I would like to discuss, and very happy also to answer questions and engage. I think it's podcast, so it's a great format for that. So I've did webinars in the past where I speak a lot, but indeed, I'm happy to experiment this new format and more of kind of podcast so don't hesitate to interrupt me, ask questions. That would be a great way to engage. So shall we get started, Paco?
Wonderful. Yes, please.
All right. So yes, let's do a bit of presentation. So I represented a company called Linkurious. So we're based both in Paris. I'm actually in Paris right now, and then in the US and the East Coast. So we're a leading company in graph visualization. So we have 50 around employees, and we are happy to be able to collaborate with roughly more than 10,000 users across the world, from United States to Australia to India, even like in the Middle East, all across Europe, and to bring the power of graph technology to the business user. So really what is at the very core of Linkurious is how can we serve and present the power of graph technology, graph analytics, graph visualization to business users. So with minimal code, minimal development, and user interface that are really designed for business investigation. A little bit about myself. So I'm the head of customer success at Linkurious. Basically, what it means is that I work with a team of customer success manager, and we cater to clients, so using post-sales with everything related to onboarding, to training, supporting clients in reaching production, so making sure that users have the best experience possible with the tool on all aspects, either technical, but also finding ROI with the platform. As you mentioned, I have a bit of a background in anti-financial crime. So before joining Linkurious, I was actually working in BNP Paribas, which is the biggest bank actually in France and even I think in Europe, where I was managing a financial security department. So dealing with anti-money laundering investigation, fraud investigation. So it's really I would say it's a passion of mine. It's like a strong interest of mine is how do we bring the best technology to these use cases, to those business challenges. And when I actually joined Linkurious, it was, and it still is, to make sure that we still stay relevant in that key vertical, which is still a very, very powerful use case for graph, which is anti-financial crime investigation. So today, what we propose as an agenda is to present the no-code entity resolution in Linkurious. So typically, what it means actually to be able to leverage the power of sending entity resolution directly in Linkurious, and how does it make it possible through that to actually build and visualize entity resolve knowledge graphs. So of course, we'll do a demo based on the ICIJ dataset. We'll explore the results of those mappings and the results, and try to look into some of the resolved entities. That is the output of the integration with Senzing. What we'll do is that, since really my focus as a head of customer success is real concrete applications of graph technology, we like to take use of some of the like success stories and real life investigation, FinCrime investigation, empowered by graph technology. So we'll take you through some of those stories, and then I guess, Q&A, of course, with great pleasure. So let's go ahead. So first of all, indeed, what is entity resolution? Since that's kind of like the main topic today. But before that, I was actually, I think it was no longer than yesterday, I stumbled across a very interesting LinkedIn post from a person called Tony Seal, who his job description is the knowledge graph guy on LinkedIn, and he always shares some very, very interesting insights on the importance of ontology, semantics, and being an evangelist for graph technology. And his post was basically saying that his experience with rope climbing has taught him that the moment when you fear, or when you feel like fear, is the moment where you actually the most need to relax. And he put that in perspective with the wave of AI, saying that AI is here to stay. So as a CEO, as a head of customer success, as a technology provider, as anyone within an institution, if you fear about the wave of AI, the impact on your business, the impact on your job, the impact on your possible skills, for example, it's actually the moment where you need to, step down a little bit, take a step further forward, and actually relax. Meaning, AI is here to stay. So what you need to actually do is relax and focus on your data. So this is why I was here, keep calm and clean your data, meaning that AI is here to stay, GenAI is here to stay. So don't worry about that. What you need to focus on at the moment is actually cleaning your data. So I wanted to open up a bit with that, and saying that, a big part of cleaning your data is making sure that you're not storing and building duplicates in your data along the way, and hence the notion of entity resolution. Here, indeed, ironically, there are many names for entity resolution. So deduplication, entity linkage, fuzzy matching, all that relates to the same concept and the same reality, is that data is often messy. There are a lot of different databases, silo data that create human error, for example, that create duplicates, and all that gets in the way of actually leveraging this data as an asset rather than a burden for your organization. So the idea is that we've seen it's really imperative, the question of the concept of data cleanliness, that is that today it's become, especially at Linkurious, we aim at building decision intelligence platform for clients, is that it's really imperative to have a full understanding of the context to make the right decision. And when we say context, is all the data and all the in the environment of a specific entity, whether it is a client, an organization. So all the data that you can collect, and that of course you're allowed to collect and build upon around the entities in your organization, and having the right context and the full context, it's meaning having data that is clean and of course not duplicated in your databases. So, and why is important? So, and how do we actually, why is important, especially if you ask to us at Linkurious, is that we're aiming at building a decision intelligence platform with at the very core, the engine, of course, graph technology. But to be able to do that, how does it work? Is that basically clients typically mix internal and external data. Why? Because you have your internal data, but more and more there are data providers that allows you to leverage third-party database providers on, for example, UBOs to compensate where you might be lacking data. OSINT data is very important as well in the fields of fraud, AML, intelligence, forensic. And when you're combining both, inevitably you're creating, or you're at the risk of creating duplicates. So we really wanted to integrate entity resolution as a key component of a decision intelligence platform so that the output is the best possible for the business users, meaning that they're able to work with data that is consolidated and cleansed through the process of entity resolution to make more confident decision and be able to confidently combine internal and external data. So coming back to actually what is entity resolution, and I guess if you're here, you're already familiar. If you're part of Senzing community and familiar with Paco's activity, for example, on social media, you're very familiar with that notion. But basically, at the core of it is the ability to recognize when there are, for example, clear duplicates. So, for example, on the entity one, Bob R. Smith II and Robert Smith Jr. with the same address and same phone number are clear duplicates. But not only that, which is, I would say, still pretty good, but even beyond that and recognize that, for example, Robert Smith Sr., which is pretty close, but obviously being culturally aware of how names are structured, for example, and the Anglo-Saxon culture, Robert Smith Jr. is most likely related with having the same address, same phone number, perhaps living in the same household of Robert Smith Jr., but obviously not the same person. So that's the very core of it, is the job of recognizing duplicates, but also building and enriching connections based on likely relationships and relationships between the entities and individuals and company. So at the very core of it also is what Senzing does, and what we worked on integrate within Linkurious is the concept of the entity-centric approach. And for that, I'm happy to have here Paco, and I'll prefer to lead it to you because I think that's the very core of the value of Senzing. Right.
Thank you, Thibaut. In this diagram here on the left-hand side, say you have a few records. You've got Bob Smith II, Robert Smith Jr., Bob Smith, aka Bobby Jones. There's an alias, and you have address, phone number, etc. And you're looking at these records, but then another record comes in for Bob Jones. One of the problems is if you're just trying to match record to record and maybe doing like fuzzy string match on some of the fields, you will miss these cases where, like for instance, here somebody's coming in under an alias. You'll miss the fact that this is really the same person who is trying to hide. So what we're doing with entity resolution, we call this entity-centric learning. The idea is we look at the different features across the data sets, names, addresses, birthdays, tax codes, etc., and also affiliations, like maybe people are in the same household. We look at all this and we kind of triangulate to try to find where's there evidence for entities which are explainable, either to say merge some of them or disambiguate some of them. Does that?
Yeah, I think you explained it far better than I could have done. So indeed, and we'll show that a little bit during the demo, how it's done. But indeed, these are at the very essence of like the logic, and I would say the power of Senzing that we're really aiming at adding and integrating within Linkurious. So how does entity resolution actually is applied within graph data? It's very important because Senzing, or I would say, is the engine, and Linkurious through the graph, what we aim is actually giving the visibility and the explainability on how entities are being resolved and connected, and building on the entity resolved knowledge graph. So how does it work? We have a very a quick example here of what's a representation is that, for example, you would have this subgraph of an individual, node A, with some attributes connected to this individual. You would have typically another subgraph with this individual here, with all the also attributes here. So you have two subgraphs here. And as you can see, for example, entity resolution would find that indeed they share some common attributes. For example, it would be the same address or similarities in either the name, but also like a phone number. So different key attributes. Either we'd call it PIIs, differently personal identification information, KYC information, but that really represent individuals, entities, legal entities in your company. And the idea is to be able to consolidate that into one single graph, reconciling the two duplicates. And the idea is to be able also with that to build upon this consolidated graph, which at the end gives a clear visibility and a better explainability to our users on what is in their database and what kind of networks they're dealing with. So having just one single network of consolidated entities and what are the possible relationships to this consolidated network. So why is entity resolution even a problem to consider? So, well, most likely I could have opened also with this slide, but what I wanted to say is that it's not only, of course, a matter of data being stored in siloed different databases within entities, within the organization. It's also could be a consequence of human error in non-structured databases, natural data variations, or their cultural differences in data. For example, one person would be, for example, in the subsidiary of a bank in China, for example, would be spelled in this way. And the other way in the subsidiary in the United States would have a different spelling, for example, being able to recognize that and reconcile it. But also what I want to say is that, and why it's important for financial crime is that data for entity resolution could be very key to even spot and identify intentional misinformation, either around synthetic identities, but individual clients intentionally misspelling or created to enable to obfuscate or as a part of a kit, for example, of synthetic identities. And to exemplify a bit on this idea of leveraging entity resolution to uncover specific risk in terms of financial crime, sanction evasion, for example, dealing with sanctions or politically exposed person, is that in that kind of use cases, typically what you would do and what a financial institution, for example, aim to do is mix both internal databases. So you would have your companies here with that could be owned by individuals like Officer Mr. Smith here. And when you're bringing external information in order to from, for example, third-party database data providers, it's very important to be able to link that and reconcile that with your existing data. And doing so, if you're able to keep that consolidated view, you're able, for example, to identify here that this Mr. Smith that was imported through third-party data was connected to also another company that was in turn connected to sanctioned individuals here, like Mr. Zukov or Mr. Gamian, and to identify that potentially the whole network is at risk. So it's just an example to show that it's not only about dealing with, I would say, data that is not clean due to human errors or poorly, I would say, maintained databases. It's also very much about identified areas of risk in fraud management, anti-money laundering, or dealing with sanction evasion risk, for example. So then what I want to do is to delve a little bit more into our partnership, I would say, in how we actually integrate entity resolution and Linkurious Enterprise. What we really so wish to do is to, as I'd say, combine Senzing and Linkurious to build an entity results knowledge graph, and to leverage all the rules in the Power of Senzing engine directly in Linkurious with, say, the no-code approach, meaning that the integration, we handle the integration. What basically administrators only thing to do is configure the mapping, and then the rules are ready to be applied to the existing data. So what it allows to do then is to find and consolidate duplicate entities. So where to find and explain and show to users, for example, in a graph where there are clear duplicate entities, but also discover hidden connections between entities. So for example, entities sharing same address, which is not an indication that they are duplicates, but this is what we would call network enrichment. That we'll see in the demo, but it's really two aspects: is finding the duplicates, but also enriching networks with close matches and possible relationships. And so just a quick overview of how it actually works and an overview of the architecture without getting too technical, because it's not my strong suit. What I really want to focus is on the business application, but really if I can say something is that the power of that is that basically the whole entity resolution is not in that case handled at ETL level. So it has no impact on the ETL. You keep the entity, organization would keep the same ETL process. The difference here is that Senzing is already integrated in Linkurious. So meaning that the data is sent directly by Linkurious to the Senzing engine. The Senzing engine detects entities through the mapping that is done by the administrator. Typically would be to map the fact that a Senzing category such as person, for example, corresponds to, for example, an officer or a shareholder in my graph database. And based on that mapping, Senzing will find the duplicates, find the possible relationship, and serve that directly in the graph user interface. And that can be investigated either case by case if you're building alerts to show those duplicates. And so that's the very core of the architecture. If I could stress something, is that it's directly integrated. The consequence, or I would say the benefits of that, or is, if I could and perhaps stress a couple of things, is that it optimizes, of course, the total cost of ownership of the whole structure, that we really want to put a focus on explainable results. So I'm meaning that it's making it able for the users to understand why some entities have been shown as duplicates or found as duplicates, why some additional relationship has been found, and really to avoid being sort of like a black box where stuff is handled either at ETL process and that it's not super clear why some entities are considered duplicates. It's really to make it as explainable as possible. And if I could stress another thing is still, I would say, indeed a strong emphasis on built-in privacy by design. The idea is that Senzing is, and Linkurious as well, is on-premise, meaning that it's not connected to any either external application, or it's not calling external API. It's really at client level with totally control in privacy on your data. So I guess it's time to go a little bit to go actually in the demo. So I wanted just to mention it, but at the moment, I would say that it's the beginning of our partnership. It's a beginning of a great story, I would say. But the idea is that we are releasing at the moment a beta integration, meaning that it will be available to clients to trial it, but it's still a beta integration. So we're still learning along the way. We still already have some very powerful results that we can show, but it's a beta integration. We hope to serve that and feed on client feedbacks to keep on to keep on improving it. But yeah, I wanted to put that out there. The demo quickly works. We work with the ICIJ offshore database from the Panama Papers. Basically, I guess you're already familiar with that kind of data, but at the core of it is basically companies, officers, so individuals Officers could also be companies, but so basically companies or individuals that control as officers companies, and addresses. So that's kind of like the basic data model, or how the data is modelized in the graph database, in which we can find duplicates and possible matches and additional relationships. Just some benchmark on some numbers or some results that we got actually working and using Senzing on this data set. And so we had a 1.95 million number of records in the original data. And when we ran the integration via Senzing and analyzed it in Linkurious, what we found is approximately 130K number of duplicates, which is approximately a 4% compression rate of the entity resolution process. So that's already pretty strong results. But interestingly also is that we find also a number of possible relationships and added new relationships via the entity resolution. So not duplicates, but possible new relationships based on proximity on some of the attributes shared by individuals or companies. We'll see that in the demo. Yeah, let's go right ahead. I'm going to share my screen. Share screen, entity resolution. All right. I guess you should see it by now.
Yeah, looks good.
Okay. All right. So what you're seeing here is, so you're in Linkurious Enterprise, our product, and what you're seeing at the moment is the interface that would be basically handled by an administrator that allows him to run the mapping and start the entity resolution process on the data. How does it work? You can see the mapping. So at the moment, we're mapping two node categories, officers and entities. That, if we look into it, how it works here is that basically entity type is the type of Senzing attribute, the type of Senzing categories. And basically we ask him, or we configure it to relate that, to link it with the central node category in my graph data that is officer. The idea here is, and what is pretty neat, is that I can be very specific. Maybe I have other types of persons or like in my data, such as, I don't know, beneficial owner, secretary, shareholder. But so the idea is that I can be very specific. I don't have to run the ER process on all individuals or person in my data. I can be specific and say, no, I want it only to run it on officers, for example. And these are the series of attributes that will be used to calculate the percentage, I would say, of match between the different officers that would find. And you can see here, you have the entity attributes from Senzing and the equivalent in my graph database. Same thing here for the entities. So that's the principle of my mapping. I run the ER process and I already have some interesting metrics. I can see that initially we had ingested 238 records. Senzing and Linkurious created 104 entities. Basically, what it means is that it has found some duplicates and created additional entities to show those duplicates and explain them. We'll see that in the demo. We found 77 duplicates, possible duplicates. So here it's Senzing being conservative, showing that it's a possible match, and letting also, in that case, the user decide if it's a full clear match, or if perhaps it will become a full duplicate if we have more data, if the data updates. And so at the moment it's that. And interestingly, we'll see we have possible relationships that have been added to the database so finding that two entities, two individuals, two companies are not exact match, but most likely are related. So let's see that. For that, I'll go into a new visualization. Let's create a viz here. I wanted to show one that was pretty interesting when doing the one individual here. So an officer called Wing Lim. As you can see, we have a series of properties, attributes on that individual. If we expand the relationship to that individual, we can see that he is connected with an address. He is the officer of a company here, and he is connected to a resolve entity created by Senzing. So this is really the result of the entity resolution job, is this new entity here. So let's expand that. So what is interesting is that, okay, now I have this entity that is the consolidated, the resolved entity. I can see here that it's connected through this individual here, and I can see that the connection is resolved, meaning that the match key being name plus address plus employer. So the three attributes here were enough here to consider that this is a clear duplicate, and we can see that those two are being resolved. So here, through the graph in the entity resolved knowledge graph, I'm able to see and quickly understand that those two individuals, entities in my graph, are clear duplicates. But this is not the end of it, because as you can see, with this entity resolved entity here, I have indirect connections to other individuals. So let's see that. Let's see how, so I'm doing it. So I can see here that this resolved entity is a clear match. We have so clear match between those two individuals. So here, for example, you can see that I have 100% match here between those two individuals based on the address, the employer, the name. But what is interesting is that, so I don't have possible match, but I have possible relationships. And I have possible relationship, for example, with an individual called Mad Tenku. If I look into the record, I can see that, well, of course, they have 100% match on the fact that they are both person. That's one thing, but we don't have a great match on the name, but we have 100% match on the address. And what is interesting is that in my graph database, the address was not put in the same way. As you can see, there are some slight differences in the address, but there are some differences. So in that case, in my graph database, there were modeled as two different addresses. But entity Senzing was able to find that it's the actual same address. The consequence of that is that if we look into Ahmad Tengu, if we expand the relationship, we can see here the individual, Ahmad Tengu here. And we can see here that indeed he is connected to an address here. And it's a similar address as this one. So I can see here that these were two different addresses. And without Senzing, I would have never been able to find that Ahmad Tengu is indirectly part or connected and possibly part of the same network as this individual. So if I extrapolate or put it a bit further here, I could say that possibly if this individual was a politically exposed person or a sanctioned individual or any kind of individual that had flagged as risky, through Senzing, I'm able to propagate the risk of this individual to my whole network here through this match here. So I wanted to show that because it's interesting in the fact that here's a clear example that through Senzing, you're able to show how you can find some clear matches here, some clear duplicates, and then work on cleaning those duplicates, but also doing some network enrichment through non-obvious connections, relationships, through actually the same address, similar address, but that was not previously modeled as such in my graph database. So, I mean, it's just a small subgraph of it, but consider that I could also continue doing so. So, for example, I can bring a lot more nodes in my database, in my graph, for example. Let's say I want to bring in all address, entities, officers to my visualization, so I can run a quick query here. As you can see, I'm not even writing any kind of cipher code on the fly, creating some queries through this feature. I can add the results to my workspace, and I can work on this data and start, for example, for individuals, start looking into possible duplicates, understand, and within in some clusters of data. For example, here it's interesting. I have a big cluster. I have this entity here, which is a resolve entity that connects to a lot of different duplicates. So I can continue doing that and continue identifying the duplicates, the possible relationship in my data. Obviously, it's one way of doing so. We could also, for example, think of building an alert for each new duplicates or each new possible relationships and investigating one case after the other, for example, and letting the user assess if a possible relationship is interesting. If they're at the moment, for example, using the same address, but it's a large, for example, building, for example, perhaps that same address is not very interesting. But if it's like a small condo, small house, that same address is more interesting to be to investigate. So as you can see, we really want to bring sensing into a graph and to let users see the explainable results of entity resolution. So that concludes the demo here. I'm not paying attention to the chat at the moment, but if you have questions that are related to the demo or that could be answered, let me know. Otherwise, we can delve into some of the graph-powered financial crime investigations that we wanted to talk about. Where do you think?
Well, we do have a couple questions. If you have a moment, we probably would be good to handle in stream.
Sure.
One from Veronique. She's asking about, when you say entity, there you go, up on screen, talking about persons and companies. And then there's really a second part. She's trying to figure out, in a specific use case, is there a typical range of the number of entity types? Or does this change a lot from one use case to another? Is it something that you get characterized as maybe being tens, hundreds, etc.?
Okay, so let me try to make sense of the question. Could you put it back to the screen? Sorry. There was two part of it. When you say entity, you obviously mean person and companies. What are the types of entities you typically deal with? Is it a very short list? Do you need many different kinds of entities? I can give a first part of the answer. Maybe if you want to complement basically the power of sensing ER in integrate, it's mostly on when you have data with entities and individuals. So this is where the entity resolution engine works. Obviously, there is a large number of attributes that sensing knows, and is able to use to create the matching scores. So I didn't show that in the mapping. I think there was a number of 6 different attributes, but there's a wider list of attributes that can be leveraged, such as like social security number, phone numbers. And I think, does that answer part of the question, Paco? What do you think here?
Yes, I think so. It also highlights a really important design question. On the one hand, yes, primarily looking at people and companies, could be looking at vessels, but something that you brought out, which I think is an important criteria, entity resolution is providing some view of data quality, some statistics about here are names, here are different forms of names, here are social security numbers. Maybe you think that an identifier like a tax code is supposed to be unique, but then it shows up in one field 5,000 times. So we get some information about that. And what this leads to is, as we're saying, there are attributes. The question is, do the attributes become nodes in a graph or they become properties? Because it may be, for instance, a business address in Wyoming is used to register, 1,000 different corporations, shell corporations. And this is a great signal in a graph. In terms of graph analytics, it can be a great signal for trying to determine if something is a shell company, because there's just an impossibly large number of companies all the same address. So the question is, do you break that out in the graph structure as a as a separate node with different relationships. And that's where I think you get into some of these questions of like maybe not entity types and entity resolution, but entity types in the graph.
Okay. I'll see. I don't think I have a perfect answer for that at the moment. I know Veronique, so if she want to discuss that further, please. So I'm pretty sure it's the Veronique that I know. We've met a couple of times in Paris. So I'll connect. I'll reach out to you on LinkedIn, Veronique. That. Okay. And okay, so I mean, let's see. Cautious of time. I did wanted to a second part. So yes, so the idea is that we wanted to make that a two-part session. The idea is that entity resolution, and the message we wanted to stress is that if you're looking into really making the most out of graph analytics, so graph algorithm, even building machine learning, it's really, well, it's kind of like a boring thing to say now, but it's typically the garbage in, garbage out story, is that it's imperative to have some clean data in your graph database, either because individuals, because of human errors, but also individuals intentionally obfuscating or messing around with the data. And what it allows to do is to really make the most out of the graph in financial crime investigation. So what I wanted to do is to highlight, I would say, 3 stories around graph investigation and graph analytics in the financial crime. The first one we wanted to talk about is a client of ours in France who specialize in what we call buy now, pay later services. And it's pretty much very prone to fraud, because basically it's usually small amounts of loans, and clients, basically the deal is that, they go to, for example, an Apple store, they purchase, and the idea is that they can do split payments. And the I would say the game is to be able to get those credits through synthetic identities, and of course, never pay back. So it's really a big challenge in terms of financial loss for this company. So they went through graph investigation because what they needed is to very quickly and efficiently make the jump between isolated fraud and large-scale networks of fraudsters. So what they wanted to do is make the most out of all the data that they're able and, of course, allowed to work with. So like the customer PIIs, digital banks have a lot of digital fingerprints through banking app logs, data on companies, and also the internal data such as credit requests, credit cards, bank accounts, transactions, OSINT data from social media, data leaks, for example, and run some kind of common use cases for graph. And I mean, one was, for example, which credit requests are connected through shared PIIs indicating potential synthetic identities or large-scale fraud rings. And so that was the main challenge that they have. And the idea is that they had a hard time identifying quickly a network, and to be able to build upon network identification to prevent new credit requests that are possibly related to that network from being improved in their decision systems. So that's kind of like a race against time. So it was imperative for them to be able to be proactive on that. The kind of like challenge or questions I would say or that they wanted to deal with is that, for example, that clients or credit requests, more likely here, A, C, B, have been rejected in the past. You have an incoming new credit request, D, that is connected to a credit request that's been rejected through a same credit card, and another one that is connected through shared IP address. So which connection is risky? Which connection is suspicious? And how do we leverage that to be able to stop those credit requests before they're being approved? So we work with them in implementing graph algorithm. The main graph algorithm they implemented were around community detection. So the idea was to leverage on all the PIIs, digital fingerprints that they were able to put in the graph, to associate those kind of connections with a certain weight. So maybe an IP address has a lower weight than, for example, using the same share on the same device. And according to those weights, create new relationships that will connect clusters of credit requests in their data. So what we did is to be able to use this kind of algorithm scripts that were run through a Neo4j graph data science library and present that in the form of alerts, individual cases that can be analyzed one by analyst. So the results were pretty great because they were able to group credit request part of the same communities and find possible also bridges or links with other communities of, so maybe one communities is not suspicious yet, but if you're able to build and find a bridge with a already existing suspicious community, then the whole cluster becomes suspicious. So that's a really great project that we're working with them. And what they said is that they were able to, of course, increase the number of avoided fraud, which is, of course, the number one ROI that you expect from a tool such as with Linkurious, but also to really improve their awareness of, I would say, of graph patterns or fraud patterns. So the idea is that if every day analysts are exposed to a holistic view of communities and fraud patterns, their, I would say, awareness to evolving and new incoming fraud pattern is significantly increased. So what they said is that before it took them approximately a month to identify a new fraud pattern, for example, a data leak coming from a major, for example, administration in France, for example. This data leak is being used by fraudsters to create kits of synthetic identities, get credit requests, and it took them approximately a month to identify that and stop the credit requests that were using those kits of this specific email address, this specific phone number. And now it takes them approximately a week to identify that and sort of like vaccine their model upstream using that information. So Money Mules also is a very interesting use case for Graph that we worked on quickly, but Money Mules basically is the idea of someone who transfer or moves illegally acquired money on behalf of someone. The idea is that, and why it's very difficult as a challenge for anti-financial crime departments, is that they explode the fact that trusted accounts face less scrutiny because money mules or financial fraudsters use existing bank accounts owned by unsuspecting individuals to move money across other bank accounts. And well, they face less scrutiny because they have not been identified as risky accounts in the past. And they also rely on small transfers of money, small amounts that often go unnoticed. So I like this image here because it highlights really the challenge of money mules and how Graph actually allows to make the most out of, I would say, low signal. So the idea is that most of the role-based systems, they relies on defining the outlier. So transactions that go above a certain threshold, and really the money mules, they are in those corridors of normal behaviors. So Graph allows you to find the connections and make the most out of the low signals that otherwise would go unnoticed if you rely on the outliers. So what is interesting is that money mules at the end can be very much modeled as a graph, where basically you would have incoming funds, bank accounts, transiting through hub accounts, funds exiting the institution. And what we did is that we, based on a lot of customer feedbacks, we were able to replicate some data typically used by banks and try to sort of like play around with it and see the results. We work with two graph algorithms, one as Louvain to identify clusters of bank accounts within the data, so connected through PIIs, for example, and also combine that with another graph algorithm that is called betweenness centrality. then apply a specific score to bank accounts according to their I would say influence within the cluster. So what we were looking for is bank accounts that serve sort of like a bridge between external bank account, internal bank account, and we were trying to find really this corridor of money flow between incoming funds and entering the institution and how they exit the institution. So yeah, we tried to produce alerts based on that. The results we had were pretty interesting. I'm going to switch quickly to Linkurious again to just show that. As you can see here, I'll just share my screen very quickly. So it's kind of like a subgraph that we identified where we found those clusters of bank accounts with some high centrality score here. We can see that they're connected by a lot of mutual financial transaction. We've kind of like identified also this money flow of funds through the different bank accounts. And you can see that we have, and if we run kind of like a chronological view on that, we found that, for example, we had on this one, for example, here around the timeline, we can see that first we can see the financial transactions going from the external bank account to this internal bank account that is collecting the funds, that is sending them through, for example, for those kind of like hub accounts or layering accounts, I would say, within my institution. And at the very end, all the funds exiting through this bank account and being redispatched to those external bank accounts. So I wanted to highlight that in this as an example of how a money mule pattern or network looks like within a graph, as a kind of like a story of leveraging graph analytics to investigate money mules. Very quickly, because I'm conscious of time, I wanted to highlight the work of Wael Alalwani working at Opsalytics. He's very interesting, very active on LinkedIn. He has a lot of amazing stories around using graph analytics to understand or to assess the effect of sanction on Syria or individuals connected to the dictatorship of Bashar al-Assad when he was still in power, and identify, for example, has the degree of influence of the network of the people connected to Bashar al-Assad targeted by sanction, has this score decrease, as you would expect, or has it increase after the sanctions on them? So, and what he's actually uncovered, what is super interesting, is that he used a number of shortest path algorithm to uncover basically more than 130 companies created by 120 relatives of sanctioned individuals in the meantime after sanctions have been applied. So it was a clear indication that of sanctioned individuals switching the ownership of companies' assets to relatives that are not being targeted by sanctions yet. He did also an amazing work on the understanding the venture capitalist ecosystem in Saudi Arabia with graph analytics, understanding running, for example, closeness centrality algorithm to understand which venture capitalists are connected with the most shortest path to other venture capitalists, and understanding which have the most impact or ecosystem-wide influence. So to basically, if you want to enter the ecosystem in Saudi Arabia, who do you need to connect for maximum impact? And this was just a conclusion. I guess we're pretty short of time. A reflection on the specificities of graph investigation. I don't know if you want to touch on that, Paco. If we have a couple more minutes.
Yes, definitely. If you have time, you bet. Let's definitely go through.
Yeah. Okay. So yeah, it's just recently we did a talk with my CEO, Sebastien, in his previous school at Alma Mater, and we were asked what is in the field of cognitive science, what is the impact of graph technology, graph investigation on the reality or on the work of analysts, and we kind of had this talk about what is the specific learning curve of graph technology. And we went to the conclusion, or like based on our experiences, that basically graph technology is powerful. but as it has a specific learning curve, and it has kind of like a downside at first, and the idea that analysts are able to see in within seconds a very wide area of connections, several degrees of exterior indirect connection, which create kind of like this overwhelming spaghetti effect with very dense graphs that can be overwhelming at time, because where you gain a lot of time in terms of collecting data, building the relationships within entities in your data, there's kind of like a trade-off where the result is that in just one click you have this very large graph. So this is kind of like a learning graph, because before, I would say, if an analyst was accustomed to, I don't know, spending a week collecting data within different application, consolidated that into an Excel sheet, building kind of like a mental map of, okay, this individual is related to another individuals that I saw opening a second application. Yes, it took a while, but at least I would say the individual had time to kind of like build his mental map, where in Linkurious, you have that within seconds. So I would say the downside, I would say, and this is where it's important to keep in mind this learning curve of graph technology. And this is where we put a lot of emphasis in Linkurious and filtering, design, graph exploration to as best as possible avoid this spaghetti effect of dense graph. So that's kind of like the first aspect of this learning curve. The second one, where we see on successful projects, such as the one I've mentioned earlier on buy now, pay later services, is the ability to recognize suspicious networks and patterns just from the shape of the graph. This is where we've had like very interesting discussion with clients where they see a bow tie types of graph in the shape. They're able to recognize that this is a normal patterns, but when it takes the shape of sort of like a dense galaxy, or they're able to identify that, yes, this is a fraudulent pattern. And I am even able to put a name on the fraud technique or the fraud pattern that's being leveraged. So this is very, very cool, I would say. And this is on the graph where you're able to identify something purely on the topology and the shape of the graph. And I would say then after, on top of the learning curve, is the ability to go leverage the full scope of technology and leverage even like graph metrics, such as understanding the diameter of a community or a graph, a community with a large diameter would possibly be more indicative of a money laundering ring, because you have individuals sending funds called a very extended with a community with a large diameter, where a community where a small diameter is more, I would say, associated to fraud networks, synthetic identities, where you have individuals closely related through shared same identities, for example, PIIs. So yeah, it was just an interesting discussion on saying, okay, it's powerful, but it's coming with a trade-off that client needs to be aware. And of course, this is where we have graph experts in terms of managing that change and getting organization through the journey of graph investigations. That's it on my side for the presentation. I hope we still have a little bit of time for Q&A.
Most certainly. Thank you, Thibaut. This is fantastic. And I really want to highlight too what you were just describing. I was meeting with an executive at a very large bank just recently, and what they expressed was the fact that the evolution of new fraud patterns is increasing, and the time that they have to be able to discover these patterns is limited. It's not like 10 years ago there were rules-based systems that would catch most of the kinds of fraud patterns. Now, especially when you get into more digital banking and getting into, say, crypto and other areas where you get really complex flow patterns. So I'm so very appreciative of what you're describing. This is more of a formalized approach to leveraging graph analytics so that we can start to understand these patterns and catalog them.
Yeah.
And recognize.
Yeah. And I'll take it back with kind of like related to what you just said, is that I think what is interesting also with graph, and graph analytics is that it allows you basically to follow two approach, which is the complementary is the idea that I know what I'm looking for because I'm aware of this specific fraud pattern, but from there, I'm able to get the full scope of the network, get the full context around a specific individual that I'm already aware of. But what also graph allows you to do, and for example, the first approach would be for a level A analyst, for example, or first line of defense, for example. And then you would have like more, for example, second line of defense or auditors that could leverage actually a second type of approach with graph that would be, I don't know what I'm looking for yet, but I know I'll know what I found when I'll find it. And this is typically where, for example, it's very powerful in graph because you're able to very quickly query large amount of data, visualize it, identify where you have clusters. Are there interesting clusters? Do I see those kind of clusters being repeated across my database? Do I see those clusters being repeated through time? Is that associated with a new type of patterns, with a new fraud technique? And then do I need to update my models upstream? This is where graph algorithm also is very interesting because you're producing basically communities, clusters, and able to analyze them. So yeah, it's very important in the sense that it allows you to stay, I would say, keep track of the known fraud patterns quickly identified from there, isolated to large scale, but also do that kind of background investigative work where you're able to quickly understand the patterns in your data, or the known patterns, or the new patterns. So yeah, in that sense, graph is very keen to rapidly evolve fraud patterns. Yes.
Fantastic. There is one question I wanted to try to get to. I know we're a bit over time, but one question I wanted to ask, this is coming from Bradley, and he was asking about if you've seen where, yeah, there we go, we got it up on the screen. If I can paraphrase so real quickly, looking at event data or flows of activity and behavior, leveraging graph algorithms for kind of going back to, say, the digital banking example you were talking about earlier, if we can be leveraging ER and graph analytics to understand about fraud or other illicit activity that's happening across distributed ledgers, maybe across serverless workflows, different steps in assets being overtaken. And if there are any ways to bring in, say, beneficial ownership registers or other kinds of statements of legitimate use to get some kind of contrast. But again, looking at event data, event flows of activity.
Yes, obviously we have good partnerships with, I would say, open data, just like open ownership, open sanction. So we've worked on, for example, building APIs to get real-time data feeds from open sanction, open ownership, for example, and combine that within the graph database. Building the ER on top of that, obviously, but yeah, we've had example. We worked on integrations with those, and we also have an online instance where you can investigate the network around, for example, Russian oligarchs. So we worked on that. But yeah, I mean, it's something that obviously more and more clients want to do or asking for, saying, I need a real-time feed with open ownership, open sanctions about politically exposed persons, sanctioned individuals, UBO shareholders, and enrich in real time my data. So yeah, I mean, obviously, if there's a specific use case that should be discussed, I'd be happy to. But I know at least, yeah, we have experience on those two open databases. Yeah.
Fantastic. I appreciate sticking with this. I know we're a bit over time. I just want to say thank you very much. This is fantastic. Wonderful material. And we're looking very much forward to our integration and going out to market with these capabilities. And we will have a page up with resources about many of the resources that Thibaut has mentioned, and also means to contact, keep the discussions going. So thank you very much. We really appreciate it.
My pleasure, honestly. Yeah, my great pleasure. Thank you for having me.
Wonderful. Thank you, everybody.